Hi, this is Sarah from the Marlbots 3526, and today I'm going to show you the basics of using the SMUX. So first, a little bit about setting up the SMUX on your robot. As you can see here, the black box is the SMUX. It has ports labeled NXT and 1, 2, 3, 4. First, you're going to connect a cable from the NXT port into a sensor port on your NXT brick. It can be whatever you want. I'm doing sensor port 1 here. The next part is to attach your sensors. I'm using a touch sensor, and the great thing about the SMUX is you can configure it any way you want. And I'm going to put my touch sensor in sensor port 1. Make sure you know where each sensor is plugged into for the programming part. There are two LEDs on your SMUX. One turns green when the SMUX is connected to a powered NXT brick, and the other turns red when your SMUX battery pack is on. Here, both of the LEDs are on, so both things are connected. Now for the fun stuff, the programming. For any SMUX program, go to the motors and sensor setup, and wherever your SMUX is connected to on your NXT, you're going to type in HT-SMUX. Mine's in sensor port 1, so that's where I'm writing it. Then you're going to go to custom I2C sensors and select I2C custom. And this is what it should look like, and then hit OK. So the next thing for any SMUX program is your include files. You're going to need #include drivers / hitechnic-sensormux.h, and if you didn't see my last video, you're going to need to watch it to set up RobotC so this can work and your computer can access this. The next is for all your different sensors. I'm using a touch sensor, so I'm going to do #include drivers / Lego touch.h, and this is going to help me read my touch sensor. Each sensor has its own driver that goes with it, so if you're using multiple sensors, you're going to need multiple drivers. I'll include a link to the document that tells you which drivers goes with which sensor in the description box below, and it is from BotBench, so thank you very much to Xander again. So the next thing is to tell RobotC where your sensors are on your SMUX. So you're going to type CONST, TMUX sensor, and then you're going to give your sensor value an easy to use name that you can call up in your program later. I'm calling mine Lego Touch, but call yours whatever you want. Then you type in equals M sensor. So now this little menu bar is going to pop up giving you all these different options. So how this works is that the first values, the S1 through S4, correspond to the sensor port on your NXT brick that your SMUX is hooked up to, and the second values, 1, 2, 3, and 4, correspond to the port numbers that are written on the SMUX itself. So in the earlier program, I had my SMUX hooked up to sensor port 1 on the brick, and then I hooked my touch sensor up to port 1 on the SMUX, so that's why the notation is going to be S11. If you have multiple sensors, you're going to want to do the same procedure for the other sensors. So you're going to want to do, again, CONST, TMUX sensor, give it a name, and this is just as an example to show you what a second one would look like. I actually don't have one of these on my robot, but then I'm going to say M sensor, and the notation I'm using is S12, so that means the SMUX is hooked up to NXT port 1 and the sensor is in the SMUX port 2. So now I'm going to show you how to call up your SMUX sensor value inside your program, and I think you'll be surprised to find how similar it is to calling up the sensor value when you weren't using the SMUX. So here it goes. I'm going to start out with the while true loop, which is not required for SMUX programs, but it's just going to make the program run continuously. Inside the while true, I'm going to use a conditional if statement. I'm going to put in TS read state, which is touch sensor read state. Each sensor has its own read state, which will automatically appear in that little drop down yellow box depending on which drivers you've entered. Now I'm going to type in the name of the sensor value I want to call up, and I'm using Lego Touch as identified above next to the TMUX sensor. Then as customary with normal sensor values, I'm doing the double equal sign, and the sensor value I'd like this condition to happen under. A quick little side note is that the numbers you associate with each type of sensor, such as the 1 and 0 for the touch sensor, is going to be the same as when you weren't using the SMUX. So luckily, that's one less thing you have to learn. Inside the if statement, I'm going to set both of the motors to 10. So that means if the touch sensor equals 1, if it's pressed, the robot will drive forward. Else, meaning if the touch sensor equals 1 condition is not satisfied, then I'm going to set both motors to 0, meaning if the touch sensor is not pressed, then the robot will stop. So compile and download the program. If you have any problems, it might be your include files. And that's it for the basic SMUX program. Here is the demonstration of the program, which our awesome captain Sam will demonstrate. When the touch sensor is pressed, then the motors are set to 10 power, moving the robot. And when the touch sensor is not pressed, the motor powers are set to 0, so the robot remains still. I will leave some quick tips in the description box, and thank you for watching.